A new offering in Replit deployments is Autoscale Deployments, where your web app will scale vertically and horizontally depending upon usage, even scaling to 0. Let's take a look at how we can use Autoscale Deployments on your web app. Now, of course, the difficulty with launching a startup is how do we deal with the differing amount of interest? When we first launch it, no one may be visiting it for hours or days at a time. But we may post it to Hacker News and take off and require all the bandwidth and as much scaling as possible just to keep the app up. Well, Autoscaling Deployments solves this problem for us all within the REPL. It will automatically scale to 0 if there's no usage, saving cost, and automatically scale up as more users are visiting your site. This means it will automatically scale up in the amount of servers and the available compute resource available to you so that you can manage that number of users. Let's deploy something using Autoscale Deployment and see how it works. I've got a web app here that is a meetings bot, and its job is to take recordings of meetings, create transcripts, summaries, and list the action items so that you never forget what to do from that hour-long Zoom meeting. I'm using AssemblyAI in this and their API to do an automatic transcription, to automatically pull the summary, and then use their Lemma AI tool to pull out the action items. All this is really simple in terms of code. I mean, let's take a quick look. To get started with our meeting transcriber bot, we're going to sign up for AssemblyAI. AssemblyAI uses AI and machine learning to process audio of meetings, transcribe it, and produce summaries, and importantly, those action items that we're looking for. Sign up and get your API key. Once you're in, we're going to go to our secrets manager and add the AssemblyAI API key. With that added, we can access the AssemblyAI API key quite easily. We're going to start by importing OS because we'll need that to get the key later. Okay, the next package we need is going to be the AssemblyAI package. There's a few ways you can install this. You could use our package manager, or you could just tell it to import AssemblyAI. And I'm just going to run it so that it in the background goes and installs all the packages that it needs to get AssemblyAI up and running. This is part of the fun of the Replit package manager. It does a lot of the hard work for you. I'm also going to bring in UUID because I'll be using that in a little bit. Bring in a specific thing from AssemblyAI. I'm going to bring in paragraph response. And again, I'm just going to run that just to make sure that it installs everything and I'm not getting any error messages. This is a good start. So how do we go about doing it? Let's just start by writing the transcription program, and we'll turn that into a subroutine in a moment. First thing we need to do is bring in the API key. We're then going to create a dictionary to store the results and start our transcriber. Now, AssemblyAI is actually really easy to work with. It's a very simple API, and there's not a lot of things we actually have to do. The first job is getting it to actually transcribe the local audio file. So let's start by just giving it a generic name like input.mp3. And I'm going to also add some configuration to this to make sure that I get speaker labels and an automatic summarization. So with that done, we should be able to send off our MP3 file and receive back the transcript, but we need to do something with that. We need to take it apart. So the way the transcript works is that we've got each individual part as a separate line. We're going to iterate through that and turn that into one consistent piece of text. First of all, we pull out the utterances, which is the actual transcript line by line. I'm going to make a blank entry in my dictionary to store the transcript, and I'm going to use a loop now. And then I'm just going to append that to the text string. I'm also going to access the summary. Then I'm going to use the Lemma model to get the action items. Now to start with, we'll just print those things out just to show it's all working. And let's bring in a file called input.mp3. Okay, now it's uploaded, let's test it out. And there we go. We've got an array with the summary, with the transcription, and with the action items at the bottom, which is pretty cool. Okay, so with that working, let's turn that into a function that we can use when we adapt this into a Flask website. I'm going to pass it the file name, the ID of the user, and the ID itself of the transcription happening. We've got to change a few things. We need to make sure that instead of input.mp3 here, we're actually taking file name, and then we're going to add a few things at the end, because what I'm going to be using actually is ReplitDB. So let's go add that. Now ReplitDB is a really useful, simple key value store that is built into every REPL. And what I'm going to do at the end of this process is I'm going to turn off the printing out of the results, and I'm going to actually put some of it in a different place. I'm going to start by using a loop. I'm going to loop through all elements in my database for that user. I'm going to check all the files they've uploaded. And if I find an existing match in that we've already uploaded it, I'm going to update all the contents to store what we've just analyzed. And of course, when it's done that, I'm going to break out of the loop because we don't need to look at any more files. Now with that all working, let's start on the website. We're going to do a bunch more imports. So let's go to the top of the file just for style. So we'll start by importing all the Flask components we need. We're going to import the secure file name module from Workzook modules. And with all those packages imported, we should be good to go. So let's start with the Flask website. We're going to also state the static folder, which won't surprise you to learn it's going to be static, as well as the template folder, which is going to be templates. We're going to start with the root folder, and we're going to deal with both the post and get methods here. We're going to start by copying the request context so we get all the information from the request. And let's start by dealing with the upload system. So uploading files is reasonably straightforward. We'll build the template file in a moment, but for now, let's do the logic. We'll start by doing the save file method. We're going to get the file that's been sent from the form. We're going to get the base path of the file. And now for that next step, what we need to do is turn on authentication. Now, one thing we're missing here is the startup of the web app to get the authentication system to acknowledge that it exists. So we're just going to do a very simple thing at the bottom. Okay, with the web view popping up, even though it says internal error, and now when we click authentication, we can see that all working. And you'll see here that it's asking us to start the web app. That's because it can only be turned on for web apps. REPL Auth with deployments is currently only supported in the advanced mode. We're going to go and click to create our own custom button. Now, again, we need a template for this. So I'm going to go and create one. And again, I'm just going to bring the code over here because a lot of it is design. But you can see the key parts of the code that we require for REPL Auth. The first thing is a script tag to bring in the authentication script, and the second is the button code. Now that will allow you to put a button anywhere on the page that automatically redirects to REPL Auth. Back in main.py then, what we're going to do is set up an app route on the / method that immediately takes our user to a login page if they're not logged in. And this is reasonably straightforward to implement. Now, upload is going to be the first method that's run, so we're going to go into this, and I'm just going to start off very simply. I'm going to say if request.headers, and we'll start with looking for the user ID is none. That means we didn't get one. There's also the situation though where it could return just a blank string, so I'm going to have to add that in as well, or that equals a blank string. Then what I'm going to do is I'm going to return the render template for login.html. So what that means is our / page, our root page, will produce the login page immediately and stop processing if the user is not logged in. We need to add that as well to our archive page. So I'm going to bring in that same if statement, but I'm going to change the return. So checking they're logged in. If they're not logged in, I'm going to return a redirect to just our base page. Now, if we run that again to see that in action, you see that we've got a simple page with a login button, which pops us up to REPL Auth. When we authenticate it, we go back in and our username is logged. If I refresh that page now, I'm always going here. But if I try to go to any of the upload pages or anything like that without being logged in, it's going to kick me back to that login page. This is supported in the deployment, and so this is the method that you want to use. This now means that we can access a person's user ID and username, which is exactly what we want to generate their database and their file name. Oh, and let's change that to file path, because the wrong variable names. And what this will do is this will build a unique folder structure for every single user based on their unique Replit ID. That means we won't have files conflicting or going in the wrong places, and it should be a reasonably easy job to keep them all in the same place. One of the things we do need to do is check that file path exists, because if the folder's not there, it is going to error. So we're just going to do, which will check to see if the file path doesn't exist. And if it doesn't, we're going to create it. The next job will be to make a unique file name. Now, chances are users will be uploading files with the same name very regularly. We don't want to overlap them. So what we're going to do is create a unique file name based on the user's ID and the date time stamp. I'm going to start with something quite standard, the year, the month, and the day, with the hour, the minute, and the second. That should be quite a standard format. So I'm going to create a new file name out of today's date, including the second the file's uploaded. This should be a unique file name for that user in that folder. Okay, I also need to get the extension from the original file and then join those together to make the new name. I'm going to join that all together to make sure we got the upload path. So with that saved, we can actually save that file now. And we need to also bring in, now with that done, we need to make the database entry for this. And it's going to be broadly similar to what we've done before. So I'm going to add the user ID of the database into the files list. I'm going to add a new dictionary. That dictionary is going to include the original file name, the date, the path that we uploaded it to, the ID, which is generated from the date and from the user ID. So it's a unique ID for every single file uploaded, and some blank sections for transcript, summary, and actions. And notice that in actions, I've got a placeholder piece of text because that's going to be placed on the screen once the upload's complete, set to automatically refresh once the transcript has been done. So then let's call the transcript. So with this all in place, I should now be able to upload the file, create the database entry, and transcribe it. But what about the standard page then? So this code here will run on every page load to the base directory. So that means we need to pull in all those variables straight away. I'm going to pull in the user ID as well as the username, and then check to see if this already exists in the database. If it's not there, I'm going to create an entry for that user and a blank space for that user's files. I'm then going to decide what to do if it's actually post, which is to take the file, tell it what to do if the stream has finished, so the file's completely finished uploading, and then use threads to save that file. I'm going to start that file transfer and then return a redirect. Now, if I'm not redirecting to that upload page, I'm going to render the upload template. I'm passing it the variables, the username and my list. So with that done, let's create the templates folder. Create the static folder. Now in there, we need to create output.html. And rather than typing this all out with you, I'll give you the code for this, which is linked below. But key to it is we've got all our standard CSS to make it look pretty. We've got the code to deal with the file upload as JavaScript, and then a very simple input upload element on the HTML form, which is pretty standard. The code on main.py will take that file and construct our first page for us. Okay, with that done, so for this, I'm going to create a template called index.html. And again, we'll give you the code for this because there's a lot going on here. But basically, standard template with spaces for the action, summary, and transcript, a full-page copy of that. Going back to our main.py file then, we need to bring in our app root for archive. I'm only going to put the get method in here because I'm not going to use post requests at all on this page. And I'm going to define home. So let's check they're allowed to view first. We'll pull in the username, and I'm also going to pull in the user ID. And I'm going to pull in the ID of the database entry from the GET request, which will be sent as a variable in the address. And I'm very quickly going to say, if the user ID is not equal to the part of the ID that contains the user ID, which is basically going to be the string concatenated between the start and the length of the user ID itself, then we're just going to return a simple error message. Otherwise, we'll work out what the ID is and we'll show the data. So we'll pull in the files record, we'll go through them for the user. If we get the ID, we'll return the template from index.html with the username and the meeting being equal to the file database entry. Now I'm going to have one unindented there, which will say invalid ID if someone tries to feed it something they shouldn't. Now with all that going, we should be in a good place to run it. Let's rename the file to be the correct one. Stop it and run it again. And there we go, that looks pretty good. It should allow everything to work. Let's try it out. Now, if you don't want to go through all that effort, you can simply fork the REPL from my template using the link below and adding in your own API key. So we can see this app work by clicking run, but of course this is working from our development server. And once again, anything that we do to the code here affects the user's experience if we share that URL with them. The better choice is always deployments because that separates our development server from our production server. But until now, we've only had the opportunity to put one type of deployment in. Let's click deploy and see where we go. Reserved VMs are the default and what we've had until now. But let's take a look at on demand. So one of the things you will need to select is the auto scaling power. This is how it scales up and down. The first job is your machine power. I'm going to click edit here and we can adjust the amount of CPUs that the machine will have. And this is the power level for each machine that spins up. The higher the power level, the greater the cost, but the more performant it will be. And this is a really useful slider because you can see the links there. As we scale up to 2 CPUs, we can adjust the RAM. And at a certain point, certain amounts of RAM are only supported by certain CPUs, and you can see that jump as we go. Let's leave it at the baseline because I don't anticipate this site being too intensive. But for every machine it spins up now, I'm going to get 1 CPU and half a gig of RAM. Actually, let's give it a gig of RAM because that's me being a bit mean. So every machine will cost me 20 compute units per second. We also then need to set the maximum amount of machines we want it to spin up. And I'm just going to whack that to full. Potentially 10 machines at once. This means that if my website gets very, very busy, it's going to scale up to running on 10 machines in the background automatically and charge me as I go. I'll click approve and configure the build settings and go on to the next step. So this is all very similar to what we've seen before. It's pulling in environmental variables, it's pulling in a run command and a build command, and it's allowing us to choose a primary domain. And I'm going to click deploy. Now this process is all very similar if you've completed any deployment on Replit before and shouldn't have any surprises. Where the surprise is in how different the cost model is. If we have no visitors, it scales to 0, and that's an amazing difference. And if we have lots of visitors, it scales up quickly and efficiently. You'll see in this example, I'm uploading the audio from a meeting recording from Zoom. This is one I've pulled from the open internet, not one of our internal ones. And you can see what it does very quickly is it establishes a transcript, it gets a summary in the same API call, and also then pauses for a couple of seconds whilst it generates the action items. And there we go, an auto-scale deployment has been deployed. Now we can visit that app very, very quickly and we can interact with it. I can upload my file and see the conversion starting and get access to my history, including viewing the transcript if I want, as well as the summaries and the action items. I can see the full history of my deployments as before. I've got the same level of analytics and the same logs. Auto-scale deployments on Replit give you more flexibility for resources and cost compared to standard VMs.